Does it ever cross into your mind the questions, when did the dinosaurs went extinct? Or what ignited the spark of life on Earth? These questions might be confusing, but eventually everything will be clear once we explain it to you. What is geologic timescale? The geologic timescale divides up the history of the Earth based on life forms that have existed during specific times since the creation of the planet. The timescale divides the Earth's history by life forms that existed in specific periods during geological formation of the planet. These divisions are named eon, eras, and periods. Let's tackle first eon that is also composed of four divisions, namely Hadean, Archean, Proterozoic, and Phanerozoic. Let's now dive into the journey of learning, starting with Hadean. The Hadean Eon, named after the Greek god and the ruler of the underworld, Hades, was formed from the oldest eon in 4.5 to 4.0 billion years ago. This is the first time in Earth's history that a planet has been characterized by a partially molten surface, volcanism, and asteroid impacts. Due to several mechanisms, the newly created Earth has been very warm. Gravity compression, radiation decay, and impacts with asteroids. Because of the harsh conditions, there was no animal or another form of life known to exist on this period.
The Archean Eon. The Archean Eon, lasting from approximately 4 billion to 2.5 billion years ago, represents a pivotal era in Earth's history characterized by profound geological and biological developments. Geological events. During the Archean, the Earth was still in the process of cooling from its molten state. The crust was forming primarily through volcanic activity and the solidification of lava flows. This period saw the emergence of continental crust, which gradually formed landmasses known as proto-continents. These early landmasses were smaller and more scattered compared to modern continents. Tectonic activity was vigorous, with frequent volcanic eruptions and the formation of mountain ranges. The early Earth likely had a thicker atmosphere composed of gases like carbon dioxide, methane, and water vapor, which contributed to a greenhouse effect, maintaining warmer surface temperatures despite the fainter sun. Biological events. The Archean Eon is notable for the emergence of life on Earth. While direct evidence of early life forms is scarce, indirect evidence in the form of chemical signatures in ancient rocks suggests the presence of simple single-celled organisms like bacteria and archaea. These microorganisms likely thrived in the nutrient-rich oceans and hydrothermal vents. One of the most significant events in the Archean was the development of photosynthesis, a process by which organisms harness sunlight to convert carbon dioxide and water into organic compounds, releasing oxygen as a byproduct. Cyanobacteria, also known as blue-green algae, were likely among the first organisms to perform photosynthesis, gradually increasing the oxygen levels in the atmosphere. This marked the beginning of the Great Oxygenation Event, a critical milestone in Earth's history that profoundly influenced its subsequent evolution. Environmental conditions. The early Earth had a harsh environment compared to today. Ultraviolet radiation from the sun was more intense due to the lack of an ozone layer, which formed later in Earth's history. As a result, life likely thrived in environments shielded from direct sunlight, such as underwater or within rocks. The oceans during the Archean were rich in dissolved minerals and gases, providing a hospitable environment for the first life forms to emerge. Hydrothermal vents, located along the ocean floor, may have served as oases of life, offering a steady supply of energy and nutrients. The Archean Eon laid the foundation for the evolution of life on Earth. It was a time of dynamic geological activity and the emergence of simple organisms that would eventually give rise to the rich diversity of life we see today. Understanding the conditions and events of the Archean Eon is essential for unraveling the origins of life in the early history of our planet.
Proterozoic Eon. The most recent division of the Precambrian is the Proterozoic Eon, with a beginning and an end of 2.5 billion years ago and 541 million years ago. It is also the longest geologic eon. During the Proterozoic, primitive single-celled organisms started to evolve into more complex single-celled species. The more basic cyanobacteria gave rise to the single-celled, membrane-containing, nucleated organisms known as eukaryotes. Around this time, evolution started to diversify the kinds of species that can be found in the ocean. Events. Modern plate tectonics began to function during the Proterozoic Eon, when the ancient cores of continents moved over vast swaths of the planet, accumulating smaller crust fragments and occasionally crashes into the other major landmasses. Conversely, this resulted in continental rifting. About 1.1 billion years ago, a fracture almost split across what is now the middle of North America. This is the best time to see the rocks that formed surrounding Lake Superior. It seems that a continental collision on what is now the continent's east coast applied a counteracting force that prevented this rifting. Where landmasses met, mountain ranges developed. Sandstone was supplied to neighboring basins and shallow ocean by mountain collapse. Rather, streams with coils were more typical. Huge ice formation resulted in ice ages on multiple occasions. After being created as a waste product by early life, oxygen went on to become a significant part of the atmosphere.
We are currently living in the Phanerozoic Eon, which began 541 million years ago and is divided into three eras: Paleozoic, Mesozoic, and Cenozoic. During this time, plate tectonics and a stable climate allowed for complex life to evolve. The supercontinent Pangaea formed and eventually broke apart, forming the Atlantic Ocean. Climate varied throughout the Phanerozoic, with some periods being much warmer than today. Major events such as the closing of the Panama Gateway and the formation of the Himalaya had significant impacts on the climate. The last 2 million years have been characterized by glaciations and interglacial periods. Life on Earth has experienced significant changes throughout the Phanerozoic era. This period saw the emergence of various animal phyla during the Cambrian explosion, followed by the colonization of land by plants and arthropods. Tetrapods were initially dominated by amphibians until they lost their habitat, and reptiles took over. Dinosaurs and conifers dominated the land during the Mesozoic era, and flowering plants emerged during the Cretaceous.
Paleozoic era. Paleozoic also means ancient life, lasted 541 to 252 million years ago. The oldest animals on Earth appeared just before the start of this era, in the Ediacaran period. There are five periods in this era, which is Cambrian, Carboniferous, Devonian or Devonian, Permian, and Silurian. Paleozoic era is included in the Phanerozoic Eon. There are major events happened in this era, such as the breaking up of Pannotia and creation of Pangaea. There are several developments of plants and animals in this era due to the events of the periods that is included in this era. There are dramatic changes in the climate of this era, such as the cooling and warming of the global climate.
The Mesozoic era, also known as the Age of Reptiles. The Mesozoic era began after the Permian extinction event. The Earth was left in a desolate wasteland by the asteroid impact. The emergence of the first coniferous forest caused the atmosphere's oxygen content to rise by 21%. It made it possible for enormous reptiles like the T-Rex to exist. For the following 160 million years, dinosaurs ruled the planet, and thereafter the evolution of birds originated from these land sources. However, another asteroid had hit the planet around 66 million years ago, which led to the KT extinction event. All dinosaurs on Earth were exterminated as a result, leaving only marine life and a few tiny mammals.
The Devonian period occurred from 419.2 million years ago to 358.9 million years ago, was a time of major changes on Earth. The Devonian, part of Paleozoic era, is otherwise known as the Age of Fishes, as it spawned a remarkable variety of fish. The Devonian ended with a mass extinction, during which 22% of all marine families disappeared. Little is known about the extinction of land organisms at the time. Species that exist during the Devonian period. First, placoderms. These armored fish were the top predators of their time. Some species grew up to 33 feet 10 meters long. Next, bony fish. The first bony fish appeared in the Devonian. These fish had jaws and skeletons made of bone, which gave them an advantage over earlier fish. Ray fin fish, which are the ancestors of most modern fish, first appeared during this period. Next, sharks. Cartilaginous fish like sharks and rays were common by the late Devonian. These fish had skeletons made of cartilage, which is a more flexible material than bone. The next one is ammonites. These shelled relatives of squid first appeared during the Devonian period. They became very common and diverse in the later Paleozoic era, and their fossils are helpful for dating rocks. The last one is trilobites. Trilobites were a group of arthropods that had been abundant in the earlier Paleozoic era. They continued to be common in the Devonian seas, but they began to decline in diversity later in the period.
Carboniferous period, also known as the Age of Amphibians, lasted from 359.2 to 299 million years ago, during the late Paleozoic era. This period is known for its vast swamp forests. There are creatures live in this era such as tetrapods, Megarachini, Meganeura, Tulimonstrum, Conodont, Hylonomus, Pelycosaur, Synapsids, Diplocaulus, and many more. Not only animals, there are also plants that exist in this period such as lycopods, sphenopsids, chordites, seed ferns, and true ferns. This period experienced events such as increased continental weathering, erosion rates, strong fluctuation in atmospheric carbon dioxide, significant global cooling and warming events, and sea level changes that affects the living organism in this period.
The Permian-triassic. The Permian-triassic period is a geologic period that spans from approximately 208.9 million years to 251,902 million years ago. It is the last period of the Paleozoic era and is followed by the Triassic period of the Mesozoic era. The major event during the Permian-triassic period. The major event during this period was the Permian-Triassic extinction event, also known as the Great Dying. This event occurred approximately 252 million years ago
and is the most severe known extinction event in Earth's history. It resulted in the loss of up to 96% of all marine species and 70% of terrestrial vertebrate species. The cause of the Permian-triassic extinction event is still debated, but it is believed to be related to massive volcanic eruptions in Siberia that led to global climate change and ocean acidification. The Permian-Triassic extinction event had a profound impact on the Earth's ecosystems, leading to the emergence of new species and the restructuring of entire ecosystems. It took millions of years for life on Earth to recover from this catastrophic event, and it marked the end of the Permian period and the beginning of the Triassic period. During the Permian-Triassic period, a variety of species emerged and existed, although many of them were eventually wiped out during the Permian-Triassic extinction event. Some of the key species that lived during this time are the synapsids. These are often referred as mammal-like reptiles and were the dominant land vertebrates during the Permian period. And next, we have the reptiles. True reptiles began to diversify during the Permian period. They were not as dominant as the synapsids, but were becoming more diverse and widespread. Next are the amphibians. While not as diverse as they were on earlier periods, amphibians still existed during the Permian period, though many of them did not survive the Permian-Triassic extinction event. Next is marine life. Marine life during the Permian period was diverse and included many types of fish, mollusks, and arthropods. Some groups, like ammonites, were particularly abundant and diverse. Next we have are the plants. The Permian period saw the diversification of seed-bearing plants, including gymnosperms like conifers. This period also saw the emergence of the first true ferns and horsetails. The last species we have for this period is the insects. Insects were diverse and abundant during the Permian period, with many different groups occupying various ecological reaches.
The Triassic period, that starts 252 to 201 million years ago, began after Earth's worst extinction event that devastated life. This time, also the large landmass existed, the Pangaea, which had altered global climate and ocean circulation at that time, was also in existence. The Triassic is also marked by the greatest extinction of all time, so it's a time when those who survived that event have spread and recolonized. At the beginning of the Triassic, every continent in the world had come together into a supercontinent called Pangaea, a large landmass that stretched across the equator and toward the poles. The supercontinent began to disintegrate almost immediately after its creation. By the end of the period, 199 million years ago, tectonic forces had slowly begun to split the supercontinent in two, Laurasia in the north and Gondwana in the south. Symbospondylus existed 252.17 million years ago to 237 million years ago and means calf vertebrae is an extinct genus of large ichthyosaurs, of which it is among the oldest representatives that lives during the Anisian stage of the Middle Triassic in what are now North America and Europe. Neosaurus existed 252.17 million years ago to 247.2 million years ago, means in Greek for mice-like lizard with mis meaning mouse and sauros meaning lizard is a genus of Anemodontia in the order Therapsida. They are also classified as Dicynodontia, which is a subtype of Anemodontia. The Mysosaurus lives around the beginning of the Triassic period and had been a small herbivorous synapsid. Antarctica and South Africa are the only places in which fossils of this species has been discovered. Cartohincus existed 251.3 million years ago until 247.2 million years ago and means shortened snout, is an extinct genus of early ichthyosauriform marine reptile that lived during the early Triassic epoch. The genus consists of one species, Cartorhynchus single-lenticarpus, named in 2014 by Ryo Masukatani and his colleagues from a nearly complete skeleton found near Shahu, China's Anhui province. Supradapedon. Supradapedon is the extinct genus of Hyperodapedontine rhynchosaurs from mid-late Triassic deposits in Tanzania's Tanganyika region. It's known in a holotype called SAM 11704. The holotype and only specimen of Supradapedon was first assigned to a species of Scaponix, now considered to be a nomen dubium, Scaponix stockley.
The Jurassic period, spanning from approximately 201 to 145 million years ago, was a pivotal time in Earth's history, characterized by significant geological changes, evolutionary milestones, and the rise of iconic prehistoric species. Events: Continental drift. Continents continue to drift apart, shaping Earth's land masses and creating new environments for life to evolve. Mountain building. The period saw the formation of several mountain ranges due to tectonic activity, leading to diverse habitats and ecological niches. Climate changes. The climate varied from warm and humid in the early Jurassic to more arid conditions in the late Jurassic, influencing flora and fauna distributions. Evolution of plants. The Jurassic saw the dominance of ferns, cycads, coifers, and early flowering plants, contributing to lush terrestrial ecosystems. Dinosaur diversity. Dinosaurs thrived and diversified, ranging from massive herbivores like Brachiosaurus and Diplodocus to agile predators like Allosaurus and Ceratosaurus. Marine life. Marine reptiles such as Ichthyosaurus and Plesiosaurus ruled the oceans, while ammonites and belemnites were common marine invertebrates. Iconic species of the Jurassic period. Brachiosaurus, one of the largest land animals ever to exist, characterized by its long neck and massive size, primarily a herbivore. Stegosaurus, known for its distinctive back plates and tail spikes. Stegosaurus was a herbivorous dinosaur that roamed during the late Jurassic. Allosaurus, a fearsome predator with sharp teeth and powerful jaws, Allosaurus was one of the top carnivores of its time. Diplodocus, another giant herbivore, Diplodocus had a long neck and tail, adapted for browsing vegetation in Jurassic forests. Ichthyosaurus. These marine reptiles resembled dolphins and were well adapted for swimming and hunting in ancient seas. Plesiosaurus. Characterized by long necks and streamlined bodies, Plesiosaurus were formidable predators in Jurassic oceans. Pteranodon, a notable pterosaur with a crest on its head and a wingspan of over 20 feet, it soared through Jurassic skies hunting for fish. These species, among many others, shaped the diverse ecosystems of the Jurassic period, showcasing the remarkable adaptability and evolutionary innovations that occurred during this ancient chapter in Earth's history.
As we wrap up learning about Earth's long journey, let's admire how it changed over time, bounced back from challenges, and adjust to survive. From the first oceans to huge mountains, from old relics to today's wonders, every part shows how life evolved in complex ways. We should take care of our amazing planet, appreciate its different environments, and make sure we keep it safe for the future. By knowing Earth's past, we can make better choices for what comes next. Hope you all learn from our rich histories and don't forget to subscribe to our channel. That's all and see you again on our next video.